All right, guys, just got an email about problem 1995, part B. This is the homework sheet that we gave out on Thursday. It looks like this. Let me go ahead and zoom in on my computer. This is what it looks like. Those folks who were absent on Thursday, either at the college visit for Dartmouth or for any other reason, you should have picked this up on Friday. If you don't have a copy of this, please send me an email and we can make sure you get this electronically because this is due on Tuesday when you get back to school. So back to the problem. We want to look at part B, and part B says, suppose that the player using die A gets 45 tokens each time he or she wins. How many tokens must player B get each time he or she wins for this to be a fair game? Explain how you found your answer. They tell us that a fair game is one in which the player with dice A and the player with dice B end up with the same number of tokens in the long run, right? So it's basically like saying we want the game to be fair so that maybe dice A has a smaller probability of winning, but maybe A gets more money or more tokens every time they win. So although it's harder to win if you have A, you get more if you win. Maybe if you take dice B, you have a higher probability of winning, but you make less money. B is a safer bet, but you get less money. A is a little bit riskier, you get more money. We want it to be a fair game, so we want these to be equal. The way we do that is we want the expected value of A and B to be the same. We want to be like, if you get A, the expected value of the money you win or the tokens you get should be equal to the expected value of the money or tokens you get if you pick dice B. So the first thing we got to know is how likely is A to win and how likely is B to win? Well, you need to fill out your table on part A, but assuming you did that correctly, you would find that A wins 16 out of 36 times and B wins 20 out of 36 times. So I can simplify that, divide top and bottom by 2, I get 8 over 18. Divide top and bottom by 2, I get 4 over 9. So 4 out of 9 times A will win. Therefore, 5 out of 9 times B will win. So these are the probability of A winning, the probability of B winning. So remember we said we want the expected values to be the same. And expected value is going to be this probability times how much A wins. Well, A wins 45 bucks. So 45 bucks times 4 over 9 is the expected value of dice A. And that needs to be equal to the expected value for dice B. That's the only way this is a fair game. So we don't know how many tokens or how many dollars you get if you're B, but we do know that the probability is 5 divided by 9. This is actually a multiplication sign here. In fact, let me leave that. That's a multiplication sign. I want to be clear on that. Let me do this actually. Excuse me, guys. Let me do this right now in the middle of the video. I know this is not helpful, but let me go ahead and do this. You just put some parentheses on here so we know there's multiplication. No question about it. So this is x times 5 over 9. Remember, x is the tokens or the amount of money you get if you win with dice B. So we know that this times this, the expected value from A, must equal this times this, the expected value from Y. So let's go ahead and set that up. 45 over 1 times 4 over 9 must equal x times 5 over 9. 45 over 1 times 4 over 9 is 20. That must equal 5x over 9. Multiply both sides by 9, you get 180. 180 divided by 5 is 36. So B needs to get $36 or 36 tokens when they win. And if B gets $36, let me zoom out so you can see everything. If B gets $36 every time they win, then this is a fair game.